Hello guys, welcome to Smart Interviews YouTube channel. Today I will be discussing Leetcode Weekly 404 Contest solutions. So we'll move with the first question. In the first question, you are given two integers, that is count of red balls and blue balls, and you have to arrange these balls row wise, and that too in a triangular format, as we can look into the first example. So but there is a condition that no two adjacent rows should have the same color. So basically every adjacent row should be different, and we have to arrange in form of a triangle. So you are given count of balls, so you have to say me the maximum height of triangle that can be achieved by following the conditions. Now first thing, if you look here, so for the first example, it is clearly given that here we can place one, here 2, and here 3, right? So we can also, here we are placing blue, red and blue. There can be other case that we can start with red, and pattern can be red, blue and red. So this is second way. This is another way, starting with red, and this is first way, starting with blue. So we cannot say that this first way is going to solve our problem. There can be the maximum possible height can be by using this second approach also. So if you look at the constraints, and constraints here is red red count of red and blue is always less than or equals to 100. So we can do the brute force solution also. It works here. So first thing, we are going to call function with red and blue, and let's say is count answer for this is x, that is height, by following red blue blue red red blue red blue, that pattern you will be getting maximum height as x. Let's say you are following the pattern blue and red in this way, so you will be getting some y, but we will try to compare the both the things and we'll be returning the maximum of x and y, right? So this thing you are going to return. Yes, so this is the ideal way. Which one we can check all the possibilities, two possibilities starting with blue and red, and then we'll be returning. One more condition here is, so you'll be checking the length, that is you'll be checking whether the level is odd or even. Accordingly you'll be subtracting, and if it is odd length you'll be following some instructions, or you'll be writing some logic, else you'll be writing another logic. So basically this way you'll be trying to figure out the logic and you'll be completing it. So let us try to code it. So if you go to this question, first thing, you're having, here we'll write the helper function with red and blue, and next we'll be writing y, another helper function, red and blue. Oh sorry, we'll pass blue as first and red as second. At last we'll be trying to return max of x and y. Now we are having helper function, it will be having red and it will be having blue also. What you are going to do here, first thing, instead of red and blue we'll go with the variable names first and second for a better understanding. Okay, if you go with the name first and second, now how can we proceed further? Let's keep the initialize of some variable as 1, and your height will initialize it as 0, right? This is how we write it. And now let us try to follow some instructions infinite number of times, till we reach our count of red less than 0 or blue less than 0. So we'll try to simply follow that. For that we'll be checking your level, So if it is odd something like this, what you are going to do? You are going to subtract your first with first minus your sum, and else first you will be checking the condition also. If first is greater than or equals to sum, then you are going to subtract in this way. Else, what is the other way? If it is not satisfying this condition, then you are going to simply break it. Else, if second is greater than or equals to sum, you simply write second equals to second minus sum. Else, you are going to break. What about the next thing? You are going to increment your sum, and you are going to increment your height too. At last, you are going to return your height. This is how we write the code, and we have checked the condition, that is level, and if it is first, then we are subtracting, and for second also, if it is greater than sum, then again we are also subtracting in that case. And if in any case, if it is less, we are simply breaking out the while loop, because we are using here infinite loop. So we have to definitely write the break statement. So let us try to compile it. It has passed for the sample cases. Now let us submit the code. Yeah, it has passed all the test cases. Now let us move to the second question. In this question, you have to check the maximum, you have to return the maximum length of valid subsequence. For this question, the valid subsequence is, so basically, whenever you pick any subsequence, the adjacent, whenever you do sum of adjacent numbers with modulus 2, that must be equal. So whenever you do something with modulus 2, so what can be the output values? It can be either 0 or 1. That means it is indicating even number, and here it is indicating an odd number, right? So this is what it indicates. So first thing, you are given a subsequence, that is an array, which can be derived from deleting some or no elements without changing the order of remaining elements. So if you have remembered the real input of the subsequence, let's take the numbers in the given array. You should pick the elements in the same order, but you can omit some elements. So how can be a subsequence? Subsequence can be 1 comma 3 here, and 1 comma 2 comma 4, and 1 comma 4. These all these are the subsequence, and from all these subsequence, you have to find the longest valid subsequence. So if you go through the example here, so if you go through the example here, we can clearly observe, either whenever you pick any two elements, it can be odd or it can be even, right? So first of all, we'll try to write all the cases when we can get even and when we can get odd. That means whenever you add two elements, what are the cases you'll be getting even and what are the cases you'll be getting odd. So when you are going to get even number, so if you add odd element with odd element, you'll be definitely getting an even element. And even if you add even plus even, that case is also valid for this. Similarly for odd, if you add odd plus even or even plus odd, the same you'll be getting it as odd number, and here you will be getting the sum as even. So you are having these four cases. Okay, so what you are going to get with the first case, how the pattern looks for the first case. So if you try to pick the subsequence should be something like, if first index is odd, all the things, all the elements, whichever you pick must be odd. It subsequence must contain the odd numbers. So basically you'll be calculating the longest subsequence of odd numbers for this. Okay, count odd, or we can say count odd for this. And for this we'll be counting even. So every maximum number of even numbers present in a sequence, in a subsequence. So this can be the pattern. Okay, and what about this case? If you have started with odd number, then next number must be even. Can it be even here to satisfy the adjacent sum as odd numbers? No, right? So you have to definitely write odd here, again even here, so on. Similarly, if you start with even here, next will be your odd, next even, and odd, so on. So these are the different patterns we can observe clearly in this question. So how can we turn this logic into code? First thing, you'll be given an array. So whenever you are given an array, you can maintain a simple variable to count the odd numbers and to count the even numbers, and try to count the alternate numbers. Alternate in the sense it can be odd even, something like this, or even odd, this pattern. So these two patterns you'll be trying to calculate in the count alternative, and odd numbers you are going to calculate here, and even also you'll be calculating here. So for counting alternative, we'll try to do it is somewhat tricky compared to rest two. So we'll try to figure out how we can calculate the alternate sequence. It can be odd even or even odd. So let us try to write the code from the logic which we have discussed till now. First, according to your question, we'll try to maintain the parameters such as count 0, count, count, sorry, instead of zeros, okay, we'll make it as count 1 and count alternative. As we have discussed in terms of odd and even, we can make here odd, and here we can make it as, sorry, here we can make it as even, here we can make it as odd. Now let us traverse on the for loop. If the element is odd, if the element is odd, then what you are going to do? You are going to increment your odd pointer, and same way, if your element is even, if it is giving is a even number, you are going to increment your even part, right? Now, how to count the alternative sequence? Basically, it should be, whenever it comes to the odd, it must be already present in the even ones, right? So if we'll try to maintain some variable, let's say visited, initially let it be -1. Let's say if I have visited an even number, we'll make it as 0, and if it is an odd number, we'll make it as 1. Okay, so whenever you want to count alternative, definitely it should not be visited should not be 1. Okay, then you will be incrementing your alternative, right? And you will make your visited as 1. Similarly, if visited is not equals to 0, you will be incrementing your count alternative. and visit you will be making it as 0. That means we are not just yet visited. At last you are trying to return max of 3 variables, that is count 0, sorry, it is odd, right? Odd and even. So let us make it as odd, count even, and count alternative. So this is how at last what are the variable is having the highest count, that itself is your answer, right? That we are going to return. So this is all about the code which logic which we have discussed, and we have converted that into code here. So it has passed for the sample cases. Now let us test for the rest of the cases. Yeah, it has passed for all the other test cases also. Now let us move to the third problem. In this question, you are given an array, and which is similar to the previous problem. Previous problem stated that only we are going to have here, it will be mod 2, but in this question it is given generalized, it is mod key. So you have to try to figure out how can we solve this problem. For this problem, first thing, if there are n elements, let's say there are n elements, we'll take the first example. If you look at this example, here the k is 2, and the output here it is coming to be as 5. So we can take entire array in the same way, and this will be the valid thing. But if you go to the second example, here k is 3, so you have to pick the elements in this way so that adjacent modulus with k equals to 3 is equal. So if you look in this way, you will be getting count as 4. This is example 2 and this is example 1. So this is a valid thing, but how can we figure it out? How can we pick the elements in such a way we get to this answer? So let's say you have n minus 1 choices. You're having n minus 1 places, right? You can either pick it or not pick it. So you'll be having 2 power n possibilities. But whenever you are trying to pick it, you'll be having certain scenario, right? What is the scenario? Your sum modulus should be equal to the previous one. So here, whenever if you are picking 0 and 1, to know whether you have to pick 2, 3, 4 or any element from the right hand side, you must know the previous thing, right? Previous element which is included. So definitely you should have the track of this one. So how can we have the track of the previous thing? Which is, if you have learned dynamic programming, it is similar to it is familiar pattern, that is longest increasing subsequence, where we have to maintain the previous number which you are going to consider for the next inclusion of the element. So how can we solve this problem? For this simple thing, we'll be having the current elements which is running from n minus 1 to current is greater than or equal to 0, current minus minus, right? So this is a current element, that is length of the array, whichever you want to pick, you can consider in that way. And what is the next thing? You have to know the modulus, right? So what is the modulus here? It is from 0, it is from 0 to k minus 1. So you can simply write here modulus array which is running from 0 to mod is less than or equals to k, and here it is mod plus plus, right? I think till here everyone is clear. So just we are looping on two things. First thing is we are having the current index. We are trying to maintain the current index. And after maintaining the current index, we are also having the modulus thing. Now we are trying to write the helper function. So how can we use this helper function? So if there is an helper function, first thing we'll be having passing current definitely, and whatever the reminder you are having, that you have to pass, and rest of the things you know, right? So you'll be passing your nums array and your key. So basically this will return you some answer and you will be taking max of that answer, and at last you will try to return something in terms of answer. This is this is how you will try to write the code in the recursive way. But how do you write this helper function? So if you look carefully how your helper function should look, you'll be having current, modulus, nums, and k, right? But here you're having your current element. That means you're passing the current and you are trying to solve, you are trying to pass current index and also the modulus, which is moving from 0 to k minus 1. Your next thing, you have to check or you have to traverse all the elements, right? All the elements from right j. If you take j, it will be like j is less than or equals to your current index. So all the previous elements, you are going to track of that. You are going to check all the previous elements. So how can you check it? Basically you have to move all the elements on the left hand side of it, and you have to track, you have to check whether it is satisfying the condition or not. So if your nums of j mod k is equals to your modulus, what are the modulus you are passing here, if it is equal, then you will be incrementing something and you will be writing here helper. What will be your current mod? So your your modulus, you'll be having current index, that will be j, and whatever the modulus you're having, so your current mod will be nums of current mod k, right? That will be your current mod, and you will be passing the rest of the parameters here and you'll be writing. So if you look this, and you can simply use the memoization technique here. So it will be something like dp of current and here modulus. If it is not equals to -1, you are going to return it, right? So this is sample pseudocode if you look, but we'll try to figure out the time complexity for this. If you try to figure out the time complexity for this, first here you are traversing at most n times, here k times, and here also for n times. So it is somewhere like n square into k. But if you look at the constraints, your n is 10 power 3, k is also 10 power 3. So it will be turning out to be 10 power 3 into 10 power 3 whole square. So you will be getting 10 power 9, and which will give you TLE. So if you try to write the code in this way by using memoization, definitely for the memoization you need the previous index. Definitely you need the previous index, then only you will be able to track it. So definitely there should be a parameter which is having the current and the previous index, and also modulus. Also you should keep track of it. So basically you'll be having n square into a k, and what about the space complexity, n into k. So it will definitely give you TLE for this. So we have to eliminate one for loop from both the things. So how can you try to eliminate it? So if you look here, you need you are traversing for k times for every time, right? For every index you are going to traverse for 0 to k, and you're checking whether that 0th modulus is present, 1 modulus is present, whether mod is 2, 3, 4 till k minus 1. But to avoid that, we will try to pre-compute all the modulus present in a given array. So how can you try to optimize this? So first thing, pre-compute all the modulus. So you can use, what you can use is, you can use a map, unordered map. Let's say if you are using an unordered map, just you can traverse from I equals to 0 to n minus 1, and you can simply use map of array of I modulus k plus plus. Just you are going to have all the all the modulus and count of all the modulus in your given map. And next you can simply use the current and previous, whichever the logic which is similar to the LIS, standard LIS. So we can traverse till n, and here it is current plus plus. And what about your previous? And here previous is also, we can simply take previous is less than or equals to current, and you're writing previous plus plus. So you're writing these two for loops. Two for loops, it is at most n square. And whenever you are trying to check, you are trying to check whether it is present or not, right? So you're having unordered map, something like MP. Let us declare it as something like MP. But you have to check whether, whenever you're having an array, let's say if you're at this ith index, you have to check in the previous index whether it is a previous modulus, whether it is already present or not. If it is already present at that particular index, at that particular index, we'll simply take that previous count of previous mod. How can you take it? MP of that, whatever the count is there, that is dp of whatever the count is there, that is mod countless is there. You can simply take it and we can add it one here. Otherwise, we can simply add it. So in this way, you are going to get ith index. Ith index is, for the ith index, you are going to get the maximum possible answer. That is maximum possible uh, subsequence satisfying the given condition. So we'll try to calculate from 0 to I minus 1 the same way. If it is present, we are going to add it. If it is already present, we are trying to check what is the previous value and what is the modulus of it. And we are trying to somehow get the modulus and add it by 1. Otherwise, you'll initialize it 2. Because if you look at the example, definitely there exists a pair, right? Definitely there should exist a pair. So if you, even if you consider 1 comma 4, if there are two elements, the two elements itself is going to satisfy the given condition, which is equal to, right? So here already the minimum length is 2. So definitely your answer will be greater than 2. Okay. So we'll try to avoid that inner k loop, this inner loop of this k, by pre-computing the modulus. So we'll try to look at the code, we'll try to look at the code, and we'll try to understand it more detail. So let us try to code our logic, what we have discussed recently. First thing, if you have gone through the logic which we have discussed, here we are trying to store, pre-compute all the modulus in the given array. So first we'll try to do that. Simple, we'll be doing modulus k here, and we are trying to calculate modulus count of every modulus present in the given array. Now, whenever you're having particular modulus, whenever you know the count of particular modulus in the given array, then you can simply find the answer, right? So first you are trying to initialize your answer. Next, you are trying to declare vector of unordered map. Here it will be dp. Let us name it as dp for this case. Yeah, now initialize as we are declaring array of vectors. So we'll try to initialize with num size here. Now we are simply following, we are simply following that LIS pattern. So basically you are from the current you are trying to traverse the previous elements by following the given condition. So here it looks something like this, nums dot size and current plus plus. Next thing is you are having previous here. Previous will start from 0 and it will be less than current, and here it will be previous plus plus. What is your next thing? What is your next thing? Your next thing here is we're having current previous. Now we'll try to calculate the mod. Whatever the mod, it will be nums of current plus nums of previous, and we'll do the whole modulus here, whole modulus. Okay, okay. Now you have the mod. Whatever the mod which is present here, you are going to have that current, that is modulus of that. What is your next step? Your next step here is if dp of mod, whatever the mod you are trying to find, what you are going to find here, first you are going to have this mod, whatever the modulus you are going to have, and definitely as you have looked already seen what is our already given value here. So here already our nums of length is 2, right? It starts from 2, so you can simply initialize with 2 because your answer won't be less than 2 here because array length itself is 2 and starts from 2. Now you are having indices. For given index you are going to have the modulus and the count. So it looks something like this. Your map looks something like this. Vector looks in this way. Index, for each index you are going to have index comma, you are going to have modulus and the count of that modulus. So this is how you are going to get it. So first you are going to check with the given previous index whether it is present or not. So dp of previous dot find mod, it is not equals to dp of previous dot end. What you can simply do, so you are traversing, you are trying to find it but you are not going to find till the end, that is dp dot end. You are not going to find the given modulus in the given unordered map for that particular index. So we'll simply write 1 plus db of previous and mod. This is done, and your next step, you are done with the value here. Now similarly you'll do same thing for current dot find, and here we are trying to do with the modulus, we are trying to find the modulus here. So in this case, if you are not going to find, if you are going to find it, so how can you write your current modulus? Current and here mod. So it will be something like maximum of value and dp of the mod, right? If it is already present, whatever the value we got from the previous array, and whatever the thing which is already present at that given index. At last, if it is not the case, now if it is occurring for the first time, what you are going to do, dp of current and modulus will be simply value, and for every iteration you are going to calculate the maximum. How you are getting maximum here, answer and current and value. So this is how you are going to write the code, and here we are going to read an answer at last. So we'll try to compile the code. It has been, you are getting the wrong answers. So if you look carefully here, here there is a typo. So here it should be mod, right? So that is a typo. I think every other thing is fine. Yeah, let us try to compile it again. Yeah, now let's try to run the code. It has patched for the sample cases. Let us try to check for other cases. Yes, it has patched for other cases also. So if you look, if you try to analyze the time complexity here, you can click here. So it is basically n square. Only we are trying to use n square, and your searching operations, as we are using unordered map, it will be amortized one complexity. So it is n square time complexity, and it is nearly 10 power 6. Thanks for watching the video. For more such informative content, do like and subscribe Smart Interviews YouTube channel. This is Karthik signing off.